Today we will be defining the following words: Sir Francis Galton, criminalist, forensic, latent, patent, dactyloscopy, friction ridges, dusting, fuming, loop, arch, whirl, minutia, fork or bifurcation, dot, ending ridge, oval or enclosure, and island or short ridge. In this case, you will be the criminalist, a scientist who studies forensic evidence. Forensic evidence is evidence that we will be using in a court of law or public debate to prove the guilt or innocence of an individual. Criminalists are often referred to as forensic scientists. Today we will be focusing on dactyloscopy, the science of fingerprinting for the purposes of identification. Dactyloscopy. There are two types of prints that we deal with in a crime scene: latent and patent prints. Latent prints are those that are invisible to the naked eye. They must be made visible through special techniques. A patent print is one that's already visible. An example of a patent print in our case would be the lip prints found on the Diet Coke can and the Pepsi can. Fingerprints are the result of friction ridges. Friction ridges are distinct patterns of lines found on our hands, feet, and lips. The lines and grooves improve our grip and are unique to each individual. Two methods for making friction ridges visible, if they are latent, are dusting and fuming. In dusting, we apply a fine powder with a soft brush to the print, making it visible. We then lift this print with tape so that it may be transported back to our lab for analysis and comparison with suspect prints. Fuming is another method to reveal latent prints. It involves superglue, water vapor, and heat. By heating the superglue, the fumes are released and they coalesce on the print, forming a hard, permanent print. This can then be photographed and taken back to the lab as well. Once revealed, the prints are taken to the crime lab and compared with those on file. This was once done entirely by hand, but is now done by computer. Even with the use of a computer, it's still very time-consuming. By classifying or grouping the prints, the criminalist can reduce the number of suspects he or she must compare the prints to. In order to identify an individual person, then, the fingerprints are classified to narrow our search. They're placed into one of three different groups. These are loop, whirl, and arch. Sir Francis Galton is the inventor of the system we are evaluating today. In 1893, he proved that fingerprints are unique, and he developed a system of classification. His three fingerprint classification groups are loop, arch, and whirl. In a loop print, notice that the center part of the print is referred to as the core, and this area is about halfway between the tip of the finger and the crease in the first part of your finger. In this area, we notice that the ridges tend to come out from a side, loop, and go back out the same side. That's what makes this a loop. On your print, these lines may come out the other side. Either one would be referred to as a loop. Remember, we're not interested in the pattern of lines above or below the center point. For classification, we're only interested in the core of the print. The next type of print is referred to as the arch. Again, looking at simply the core area, we're looking at the lines and we see they rise and fall. They come in from one side and exit the opposite side. Arches can be very high or low. third type is known as the whorl. Notice it's spelled with an O and not with an I, but like a whirlwind with an I, the line does seem to, the lines circle around a central point. Again, we're not interested in things outside the core. It's in this center area. After a fingerprint is classified into one of the three categories, further examination will reveal characteristics that are unique to an individual print. To make an individual match, we must look at minutia points. The word minutia refers to the details, the individual characteristics or details of the print. There are over 30 different minutia points, and no two people have the same types of minutia. Here are some examples of minutia. Islands, or short ridges, are separate ridges that are not connected to a main ridge. Here's an example. There's another one, third one, and a fourth one. Again, each of these islands or ridges are all alone, surrounded by white on all sides. They may be short or long. An island that is very short, that is as long as it is tall, is not an island. It has a different name, a dot, which we'll look at in a minute. An oval or enclosure are ridges that form a circle or an oblong enclosed space. Here are several examples. Again, the oval may be very small, as you see here, or they could be longer, like you see on this one. We're only interested in the core at this point. Ending ridges. Ending ridges are ridges that begin somewhere at the edge of the print and end in the center of the print. This friction ridge line right here begins off the page, off the print, and ends somewhere in the center, making it an ending ridge. Remember, an island, you'll see both ends of that ridge somewhere in the center. A dot is just what it sounds like. Any dot found in the core is what we're interested in. Again, the dot differs from an island because it is as long as it is tall. The final type of minutia we're interested in is called a fork or bifurcation. In a fork or bifurcation, the ridges split in the core. As you see on this line here, it branches off and splits. Same thing down here, branches off and splits. To bifurcate means to branch in two different directions. In medicine, we often use this term to refer to structures that split, like arteries and veins. We say they bifurcate, they branch off. To find a match, it's not enough just to match the print type. Both of these prints are examples of arches. However, simply being an arch is not proof that they're a match. We must look at the minutia. In our presentation to a jury, remember this is forensic science, so we're going to make an argument in a court of law or public debate. I'm going to prove that these two match because islands exist in the exact same place on both prints. Same length island, I might even measure it in the same location. An oval also is found in the exact same location. Too often students jump to conclusions. They find one minutia point that matches and they say they have a match. For instance, they might notice this crease down here, the crease that you would find between the segments of your finger. Those are very common. You might find that on many people. If it's a match, every visible point on this print should be found there. I would suggest you find 3 or more minutia points that match when doing your match in class. All right, let's go ahead and print ourselves. What you need for this exercise is an index card, 6 pieces of adhesive tape, a piece of scratch paper, and a pencil. Take your pencil, darken in a patch about this big. Regular pencils work best for this. On your index card, on one side, the line side, write your name. On the reverse side, write T, 1, 2, 3, 4, putting 4 in the bottom corner. Next to each of these, you're going to place your print. T for thumb, 1 for index finger, 4 is your pinky. To print yourself, simply take your finger that you want to print, or your thumb, rub it across the area that you darkened in with the pencil. It should be dark but not black. Many people over darken their finger and then they don't get a clear print. For the first part, to complete the table in the first part of your homework, part A, place the tape across your finger in this direction. You should get the middle center part or core of the print. Take the tape and apply it to your index card in this direction. Once you've completed your card, your printed card, go ahead and classify each print as a loop, arch, or whirl. It may appear as some of your prints look like a combination of 2 or more. Make a decision. Is it more like a loop or a whirl? Which pattern do the lines follow? Do more of the lines loop out, or do they whirl around a center point? Put your identification, your pattern, in the column labeled your pattern. Trade cards with someone nearby and classify their prints as loop, arch, or whirl. When you're done with that, read the section on the Galton characteristics, then complete part D. Part D is on the next page. In part D, you are identifying the Minutiae characteristics, the 5 Galton characteristics. According to the directions, you're to draw separate arrows for each of the 5 Galton characteristics. You were supposed to identify 2 of each of these, so there should be a grand total of 10 lines, 10 arrows. So for instance, I noticed right away that I have an enclosure right here, so I'm going to draw an arrow out here to the side and identify this as enclosure. I'm going to look for another enclosure. I see one right here. I'm going to draw a separate line. I want to see 10 separate lines for each of these. And go ahead and complete the remaining characteristics, identifying 2 of each. When you've completed that, move on to part E. In part E, you're going to demonstrate that your print does not match one of the suspect prints. To do this, you must print yourself once again, as you did on the index card. However, this time, rather than running the tape this way across your finger, take it straight up and down. Go all the way down past your crease. That will allow you to place your tape print to the left of the same type of print. Here I have an arch, here's a whirl, and here's a loop. Since mine is a loop, I would take my print and I would place it right here. I would run the tape and I would put it right here. So let's just pretend that this is my loop print here with all my little minutia points. Okay? I've lifted that print off and I placed it next to the left of the same type of print. Now, according to the directions, I'm to identify 5 Galton characteristics that are different from my print and the suspect print. For this portion of the worksheet, you should use a ballpoint pen. You're going to need to write directly on top of your print. A magnifying glass might be helpful here as well, so you can really see those detailed points. So let's just say, for instance, I see that there's a bifurcation right here where it splits on this print. I notice that I don't have the same thing on my print. So I will point to that same location and number it. Number 1. This is point number 1 on my print. Down at the bottom, I will explain how this point is different from that point. And it needs to be one of the Galton characteristics. In this case, it's bifurcation. I would write I don't have a bifurcation here. The suspect does. Don't forget that period. Make sure these are written in complete sentences. For the final section, more fingerprint facts, read this section and the first page of the worksheet completely. All the facts necessary to complete this section are found on this worksheet. Make sure you answer in complete sentences, which includes number 7, 1, 2, necessary to complete.